Hello everyone. In this video I'm going to go over the solution for quiz number 8. This quiz in particular had a lot of issues in the submissions, so I want to clarify how to work with some of the main things that are explored in these topics. The topics include the rate of change and the equation of the circle. So the first question is about a machine that pours a pancake batter on a griddle. The pancakes are circular discs that are 0.5-inch thick, and the volume of the pancake itself is going to be given by 0.5 pi by r squared. And this is in cubic inches, and r is going to be the radius of the pancake in those inches. Now, question number 1 talks about let's check for the volume of two different pancakes. They have two different radius respectively, R1 and R2. And we know that the difference of the delta of the volume is the difference between B2 and B1, and we can call delta R to the difference of R2 minus R1. Now we want to find a formula that expresses the changes in volume of delta V in terms of the change in the radius. This is going to result in some sort of expression of the form delta V equals some expression by delta R. So let's actually see how the solutions for this is. So first thing is, let's establish delta V. So delta V is B2 minus B1, but we can actually compute what B2 and B1 are in each of these cases. So B2 is actually 0.5 pi R2 square, and B1 is going to be 0.5 pi R1 square. Some of you got to this point, but then what you need to do is obtain a way of obtaining R2 minus R1 so you can obtain the delta R. So what you need to do here is factor out the common numbers. So first, 0.5 pi, and this is going to give me R2 square minus R1 square. But now this is a difference of squares. So if you remember in class, we mentioned that we can use the algebra expression to just simplify this value. So this is going to be R2 plus R1 times R2 minus R1. This is the difference of squares. Okay? In the practices and your homeworks, you get to use this difference of squares, or you also get to use the difference of cubes. And those are the main things that you got to pay attention when working with this type of scenarios. Now, once that you get here, you got the delta R here, notice. So it's only 0.5 pi R2 plus R1, and this is delta R. And so that's it. This is the expression that we were looking for. Now, part B of this tells me, well, let's find the average rate of change dV dt in terms of the R dt. There's not a lot to do here. We just need to divide by delta t, since that's going to put the variation in terms of time. And so over here would be 0.5 pi R2 plus R1 delta R dt. Last but not least, then this average rate of change for the volume of the pancake was given as 1.5 cubic inches per second. So notice that this is talking about inches per second, so this is talking about this rate of change. So we're going to use the fact that we know now that dV dt is 1.5 cubic inches per second. And this is saying, but at the same time, it's asking what is the average rate of change for when the radius is increasing from 5 to 7. So what we have here is that R2 is 7 and the initial R1 was 5. So we can actually use this formula and put everything, all the quantities that we have at use. So the RDT is just going to be 1 over 0.5 pi R2 plus R1, and then the VDT. And so notice that because we know how much is R2 and R1, this is simply 0.5 pi, and then we plug 7 here, we plug 5 here, that's going to be 12. And then the VDT, I know that's going to be 1.5. So at this point is just a matter of simplifying. This 0.5 by 12 is just going to be 6. So I can see this as 1.5 over 6 pi. And of course this is in inches per second, since this is the radius. And you can see here that we're losing one of the quantities here. This is cubic inches, and then we're losing here one of those inches, and then also here we get to lose another cubic inches, and so we only get one of those. So that was it. That was the result. You can compute this in your calculator to figure out how much is that going to be. I can probably simplify this a little bit more. I can see this as 3 over 12 pi inches per second, and so that will be like 1 over 4 pi if I'm not mistaken. Yeah. But this is just a process of algebra at this point. And that was it. That was everything that we were doing here with this average rate of change. Now, for question number 2 of the quiz, we are supposed to write the equation of a circle. And so the purpose of this is that you understand how to complete the squares. So you have x squared plus 4x, and then plus y squared minus 10y, and we can write this 21 on the other side to be a negative number. So what do I need to complete this square here? Well, if you remember what we did in class, what we need to do is divide by 2 this term that is next to the x, so pretty much 4 divided by 2, which is 2, and then we're going to add that term, right? 4 divided by 2 is square. And similar with this y square, 10 divided by 2 is 5, right? So 10 divided by 2. And so 4 divided by 2 is 2, so it's 2 squared. So on this side, we're going to add the same thing that we're adding on this side. So 2 squared is going to be 4. And in here, we're going to add 5 squared. So we're going to add 5 squared here as well, which is 25. So now, this is going to help me fold out. And I'm going to be using the complete square to transform this in x plus 2 square, since it's always the number that is going to be left here. This is the first one, this is the second one, and then it folds to a square. And now here it's going to be y minus 5. And now on this side I have 29 minus 21, so I'm going to get 8. Now be careful here, this is the radius square. So if we're going to find the radius square is 8, so that implies that the radius is the square root of 8. Now the center, for the center, you compare with the x minus h square, this is x minus minus 2. So the center is going to be the point minus 2, and if you compare here the k, is going to be a 5, so the center is minus 2, 5. So that's it. This is the solution of quiz 8.